So, as per this theme of the this workshop is concerned, this is deep learning application in healthcare and technology. So, from the technology perspective, I try to incorporate some concepts that will help all the participants in order to enhance their learning as well as research skills. So these will be my contents. I will try to cover up all the contents during the presentation. So starting from the introduction to the plant disease detection, I will try to cover up the plant stress. What are the different type of plant stress we have? Then basic infections the plants have. Symptoms of a diseased plant, that how you can identify that a plant is diseased or not. And then we will discuss what is the process of plant disease identification, starting from the different techniques like machine learning we have, deep learning we have, human inspection we can have. Okay, and then we can have machine learning and deep learning approaches. We can compare that which one is better and which one we have to select. Then I will discuss the components of a plant disease detection system using CNN, and I will discuss the architecture of few famous architectures, and then I will discuss the type of disease detection and classification approaches. Different classifiers we have, so which kind of classifier is suitable for us? We have to identify those kind of classifiers, and then I will try to have some brief overview on activation functions, that what is the use of those activation functions, and why we need such kind of activation functions, and which one is suitable to us. Then popular deep learning models and architectures we will discuss, followed by the transfer learning concept that is very much popular nowadays. In case we have small amount of data, so we can apply the transfer learning concept. Then I will share some famous data sets that you can use for your research purposes. Also, I will tell you how you can create your own data set and how you can upload the data set to the public repositories. And then at the end, we will discuss what are the challenges to the plant disease detection. So I hope the participants have a brief of, knowledge about this neural network concept. So I will be starting from this convolutional neural network only. Okay. So in case you have any doubt, then you can please interrupt me. I will be happy to answer the queries. So as you know that agriculture is very important and it plays a significant role in the economy of the countries, and most of the countries are depend on this agriculture, and to produce the sufficient amount of food that meets the requirement of the society, it is very essential that the losses are very minimum. So in order to reduce those kind of losses, this computer vision and we can say AI based techniques are playing very important role. Not only AI, we have IoT as well. So that IoT and AI is a complete, we can say, these kind of algorithms are playing very important role. So until we just minimize the losses, so it is very threatful to the human life, that in order to bring the food security, the plant diseases are very much essential to be detected at the early stage. So I will cover some kind of we can say do's and don'ts in this presentation. So generally you have heard so many lectures on this plant disease detection and we can say human disease detection using deep learning. So I will be discussing some interesting facts about these kind of algorithms, that how these are useful and how you have to apply those kind of things to save the human life. Okay, so in order to minimize the losses, we have to detect the timely prediction. Okay, so early prediction is very important. Sometimes we call these algorithms as plant disease prediction. Okay, some authors or we can say researchers are using these terms interchangeably. One is the prediction, one is we have a detection. Okay, so in order to predict something, like there will be some kind of disease will be there to the plant or not, then you have to use this term prediction. In order to if a plant is already diseased, then you will apply this term detection, or we have identification. So you can apply these kind of terms whenever the situation is suitable. And in addition, we have the new thing, that is severity identification, that how much severe the disease Okay, so in order to detect the severity level, that for example you are detecting the disease on the early stage, or we can say at the later stage. So it is very important that if plant is completely damaged, or we can say 80% damaged, then there is no use of disease detection. So it is very essential that you are going to identify the disease at the early stages, so that preventive measures can be applied. So this is very important. So you are going to create alerts to the farmers, or to the you can say owners, that you have to apply some kind of preventive measures. And in order to do all these things, there is a very important term that is known as plant pathology. Okay, so I hope many of you are aware, but this plant pathology is basically study concerned with the plant and their diseases. Okay, so nowadays we are using computational intelligence techniques in plant pathology as well. Okay, and pathogens are nothing, they are just bacterium or viruses, or we can say other microorganisms that can cause the disease. So we have to identify that what are the pathogens and how you can tackle those pathogens. And this is very important, that disease detection can be partial as well as a real time. Okay, for example, you are interested in a real time diagnosis. So for that you need some other kind of additional devices that will bring you the real picture of your farm. Okay, otherwise it is partial, we can say it is not a real time, just you had captured some images like they are 4 days or 5 days old, and you are applying those kind of images, and you are training your network on those images. Okay, and we know that this computer vision is basically very important field, and this is gaining very much popularity nowadays, not only in plant disease, in every we can say image processing area that can be used in like healthcare, that can be in any other field. Okay, so this is very important, and this computer vision basically enables us, a computer, to understand and interpret the images or visual data. Okay, and this is very important. The performance of plant disease detection system using computer vision is mostly depend on the features. Okay, so these features basically and their extraction is very important, that what kind of features we are interested. However, in case of deep learning systems, features are detected automatically, but it doesn't mean that we just completely rely on the system and then we are taking features that are detected by the system itself. Feature engineering is very important, that needs to be done whenever we are going to have such kind of systems. The type of features basically depend on the disease symptoms. Okay, so sometimes the disease symptoms may be vary, and it may not be available due to such kind of pathogens. It may be due to environmental conditions like weather conditions. Okay, so you have to identify some kind of symptoms, and accordingly you can detect the features. And automated this in order to design automated systems for detection and diagnosis of plant diseases, farmer and agronomists with high throughput and precision, basically they must assist with these kind of techniques. So why we are developing such kind of things? Because we are going to assist farmers with high throughput and precision of these kind of algorithms. So we have to design systems that are highly precise. So in order to start with this plant disease detection system, you must aware that what kind of stress a plant can have. So in general, if we are talking about the stress of a plant, it is either biotic or it is abiotic. So biotic stress is basically come from this virus, fungus, bacteria, protozoa, and some kind of these living organisms. Okay. In case of abiotic stress, it is due to some kind of environmental conditions that are unfavorable. Atmosphere, we have rainfall is very high, humidity is very high, temperature is high, air pollutants. So these kind of abiotic stress. So this is abiotic stress is very much important and very much hazardous, dangerous than abiotic stress. So most of the researchers are basically focusing on this biotic stress only. Okay. However, in case of some sensor-based technologies, some IoT-based technologies, researchers are focusing on abiotic stress. So they are interested in knowing the real-time temperature, humidity, soil sensors. You are going to have rainfall data, and in order to predict the yield, that how much yield will be there. So such kind of abiotic stress is very important. that what will be the yield prediction, what is the current temperature, what is the current humidity, and what is the humidity and temperature for the last 2 years. So that data you can use to store in the cloud systems, and you can utilize those systems in order to have current data with you, and you can predict something. Okay. And as per the biotic infection plant is concerned, you can detect those plants with the help of these kind of fungal diseases. So fungal diseases, we have scrap, blight, rust, spot. So many we have fungal diseases with us. So nowadays, what is the problem with the computer science researchers is that they don't know in detail about these fungal diseases, and they just start doing some research on some kind of things, like they don't have knowledge for the X-ray images, but they start preparing some kind of deep learning models and try to identify the accuracy only. So their focus area is only that my system is having 99% accuracy, so this is my research. This is not the research, just you have to go into the insights of the diseases, insights of the images, that what kind of features they have. So in order to detect the images carefully, you must know the underlying features. So in order to start with the plant disease detection system, you must take help from any plant disease expert. Okay. And you must understand the basics, that what are the reasons for such kind of diseases. So for example, if I am talking about this blight, we can say disease. So what are the reasons for that? Some such kind of symptoms. Whenever you will deal these kind of things with the plant experts, so they will tell you that there are so many reasons for such kind of pattern. Okay, this fungal infection is not only the responsible reason for this kind of texture. There may be some other reasons for that. Okay, so you must read, or we can say have a good knowledge for such kind of things. Okay. And whenever we are talking about the symptoms of a disease plant, so disease plant symptoms means the leaf is very important. So sometime whenever we are discussing the plant disease detection system, so most of the cases our focus is on plant's leaf, not on the plant stem or the roots. We have these three important things for a plant. We have root with us, we have stem, and we have leaves. So our focus area is basically leaves. So leaf is very important. That can tell you that the plant is suffering from a disease or not. And early symptoms are available on the leaves as well. Okay, so if you are able to detect the symptom on the leaves, so definitely some preventive measures can be taken. So try to have a data set that can have early symptoms. I will tell you some we can say data sets that are very popular in this area. But if you are not satisfied with that and results are not we can say encouraging, so you can have your own data set. I will tell you how you can capture the data set and how you can pre-process that data and how you can upload to the public repositories that will help all the research community. Okay, so the symptoms, we can say, if there is a change in the color, the shape, size, and growth, so these are symptoms. Okay, at the transition state, we can say disease causing factors start affecting a healthy plant, and there is a gradual appearance on the symptoms for the disease. At this stage, it is very difficult to distinguish a healthy plant from a diseased plant. Okay, this is very important. Sometimes when we are detecting the system, generating a system that is going to distinguish a healthy and a diseased plant, so it is very important that on the early stages you have to identify those things. Okay, so you have to keep monitoring all these things on daily basis, that what was the situation of my plant yesterday and what is the situation today. Okay, and based on that you can gradually create your own data, and that will help you in order to identify the early symptoms. In addition to that, environmental factors such as temperature, wind, humidity, exposure to the sunlight, these are also, we can say, factors. And as mentioned earlier, disease symptoms and their causes can be different. So don't think that only viral or fungal infections causes these kind of symptoms. They may be due to lack of nutrition, they may be due to heavy rain, they may be due to, we can say, temperature conditions. Okay, so you have to identify all these things. It is not the case that the symptoms are from fungal infections only, and you are putting extra pesticides on those plants, but this is not the case. Okay. So whenever we are talking about this plant disease identification system, so you have to identify first that which part is very much interested, or you are interested in which type of a part. So you can have a leaf, you can have a stem, you can have a root, you can have a yield. So you can identify that if you are developing a system, so what kind of data, what kind of images this system will have. Okay. And then methodology, definitely we have these four methodologies are very important and very popular. One is the, we don't have any methodology, just we are inspecting the plants with our human eyes only. So what is the drawback of these kind of systems? Because in case we have a large amount of farms, and so it is very difficult to inspect each and every portion of the plant. So what we basically do, we develop a system that will capture the images automatically with the help of some kind of cameras that can be put on some kind of drones. Okay, so we have so many kind of agriculture drones with us, so that can capture RGB images also, that can capture, you can say, temperature images also. So just you can have insights on those kind of images, and based on that you can have preventive measures on your farm. In addition to all these things, we can have vegetation indexes with us. Okay, so that I will discuss later, that how you can identify some kind of infected area with the help of vegetation indexes. So the second one important technique is image processing technique. So we have traditional image processing techniques. You can apply pre-processing, you can extract the features, and then you can have classification. Okay. On the other hand, we have deep learning and machine learning techniques. So in case of deep learning, the features are detected automatically, and they are basically learn features themselves. Okay. So they are advanced than these image processing and machine learning techniques. So you have to identify that which part is important to you and which methodology is important to you. Based on that, you are going to identify the disease detection system. And as per the materials and methods for the disease detection system is concerned, we have materials means image data we have, and sensors data we have. Sometimes in order to include innovation in your research, researchers are basically mixing these kind of data. They are putting sensors data and they are putting image data together in order to make a hybrid system. So that is very crucial. So please be careful in doing all these things. Many times I heard from research scholars in their PhD presentations that in order to bring some novelty, in order to bring some complexity to the system, they are combining such kind of data and making a hybrid system. So better you can use these things separately. Sensor data is very important. You can put sensors to different locations to your farm, and you can gather the data, and then you can analyze those data to your systems. Okay, and the past data or the historical data is very important to you. You can also analyze those kind of data at the later stage. As per the methods are concerned, we discussed earlier, image processing and machine learning techniques are very important. In case of deep learning, we have two main things. One is the transfer learning and one is the training from the scratch. So whenever we are discussing learning, so deep learning is there, machine learning is there. So learning comes from the neurons. So as you can see that we have different layers with us. Input layer we can have a hidden layer with us, we can have output layer with us. So whenever you are providing training to the system, so it means you are just training a system to have a optimum set of weights and bias to the neurons. So what exactly the learning means, just we are going to train a system that can have optimized weights and bias. Okay, so whenever you are using transfer learning concepts, so you are using the concept of already trained networks, or we can say we are going to utilize the trained weights and bias of trained networks directly, and then we are going to customize the later layers so that we can have higher precision with us. Why we are doing all this research? Because we need a system that is having very much precision with us. Okay, so in order to increase the precision, it is very important that you can use transfer learning. In case you have a low amount of data, In case you have a low amount of hardware configuration with you, sometimes you know that deep learning systems are very much capable, but they need lots of hardware configuration. So in case of lack of hardware configurations, you can utilize the trained weights and bias of existing networks, and you can utilize those networks in case of transfer learning. This I think you all must know, but for the just we can say flow of this presentation, I included this difference between machine learning and deep learning approaches. Sometimes we are confusing that which one is better and which we should go further. So as per the machine learning is concerned, it requires a small amount of data, and you can have some numerical data with you. For example, you can have sensors data with you. So you can apply the numerical values of those sensor data in order to have predictions for your system. Like for example, in the previous year, we applied some kind of sensor to our farm, and we gathered some data that is stored on the cloud. And this time we are analyzing those data, and based on those analyses, some kind of predictions can be there that tomorrow can be the rain can be there, tomorrow we can have humidity that can be more, that can be we can have high wind pressure with us. So that thing you can do with the help of machine learning techniques. But on the other hand, this deep learning requires large amount of data. So you can see that the larger the amount of data, the higher the accuracy is there. Okay, so this point indicates that the amount of data is very high, and we can say accuracy is also very high. So this deep learning algorithms needs large amount of data. Sometimes what researchers do mistakes, like whenever whenever we are discussing the large amount of data, they are having large amount of data, but the dimension, or we can say size of images is very high. For example, you are using 512 by 512 pixels. So sometimes some authors are using 1048 by 1048 pixels images. So this will create a lot of, we can say, complexity to the system. It will take a lot of time. Okay, so just apply some pre-processing to those kind of images. So this is very high size. Sometimes you feel that you have a good size of data, dimension of the data is very high, but still accuracy is very low. Okay, so the system is is feeling very difficulty in order to get training from high dimension images, until unless you have a require sufficient hardware with you. Okay, so use these things very we can say wisely. Don't apply anything randomly that let's do a research that let's have data on this, increase the layer, decrease the layer, or change the filters, change the padding. So don't do all these things randomly. First of all, have a deep knowledge for all these concepts, have a deep knowledge on the mathematics, then you can implement some kind of systems so that you can have high precision, high accuracy with you. uh, Accuracy is a very important parameter, but this is not the one parameter that must be taken care. In at the end of this PPT, I will tell you some other metrics as well that are very important, that must be taken care in order to have a good precision systems. So instead of accuracy only, we can focus other metrics as well. Okay, so this is generally myth that if a system is very high, is accuracy is very high, then it is a precise system. It may not be precise system. Okay, so we will discuss these things later on, that what metrics you should select in order to develop a precise system. As per the hardware dependencies there, machine learning, we know that it can work on the low end systems. We can say machines or CPUs that are not much high configured, but deep learning requires GPUs or high end machines for the execution. Okay, so nowadays Google collab with us that can provide you some facility, not we can say sufficient amount, but to run to execute this kind of systems, you can use Google Colab. Okay, so I hope you can have sessions, or you had sessions on the Google Colab, how you can utilize those Colab. Okay, so that you can use. Feature engineering is very important. In case of machine learning, we basically rely on the handcrafted features. Okay, so these features basically we are going to craft. In case of deep learning, we have automatic feature extraction without human intervention, but this will work only whenever you have configured feature engineering intelligently to the system. Okay, don't rely on the system that feature will be extracted automatically. So we are not worrying about the feature extraction. So it is very important part of the deep learning system. You have to identify that you are, for example, you are performing a edge detection. Okay, in a scene. So you are interested in horizontal edges or you are interested in vertical edges. So that you must identify, and you will be telling the system that I am interested in vertical edges. Okay, so accordingly you are going to select the filters for the convolution layers. Okay, then only features will be come to you, these vertical features. Okay, as per the interpretability is there, these are easy to interpret. You know the reasons, that what is the reason behind this result, but this is very much we can say difficult in case of deep learning, and it is disadvantage of deep learning systems. You are unable to interpret the reasons behind the result of the deep learning systems. Just it is a hit and trial method. Just you increase the layer, decrease the layer, some parameters you are going to tune. So that is the fine tuning of the system. So you can't say that my system is perfect one. You know that you are reading research papers that are claiming accuracies like 98.9% is there, 99.3, 99.7% is there, but still the research is going on. Why it is going on? For example, if I am having a system that is claiming that my system is having accuracy of 99.7%, so it means the research is at optimum level in this area, and we must focus on some other areas because it is already 100. But still research is very much popular in these areas because reasons for these kind of algorithm is not clear, and they must not perform with same accuracy level, same precision with other data as well. It is not guaranteed. These results came on that particular data itself, on a particular training environment, and that may not work seamlessly on other data sets. Okay, so, and the training time in case of machine learning, we are taking very much less time. It ranges from few minutes to few hours. But in case of deep learning, it ranges from a few hours to few weeks. So if your system is not highly configured, so it may take lots of time. And so that it is very important that your parameters are configured accurately so that you can save time. If you are a research scholar and you are doing some research on Google Colab or any other system, so the time is very important to you. If you are running experiments that are running for, we can say, 7 days, 5 days, and results are not encouraging, so definitely it is not a kind of motivation for a scholar. So better in order to start a better start, you must have knowledge for all these things. Don't just try to we can say read the code and try to customize the code at your own. Just have insights, read good research papers. I will tell you some journals from where you can find out good papers and how you can read the paper. Sometimes reading paper is not known to most of the researchers. They just read 3-4 paper in a day. That is not a good thing. Okay, so I will tell you how you can read papers, what is the good way to read the papers, and without reading paper nothing can be done. So it is very important. Sometimes what we do, what mistakes we do, we download lots of papers from lots of websites, and at the end we are meshed with lots of PDF files with us, and we are confused that which file was important and which one to read, which one to not read. So few days we spent on downloading papers only, and then we are reading very less papers from those kind of PDF files. So first of all, try to identify good journals, then try to identify papers of your interest, and then read papers carefully. Take time, 3-4 days, you can devote time to one paper. Okay, so I will tell you these things later on. As per application of deep learning is concerned, we know we have so many applications, but just you can brief. Recognition and classification of crops is very important. In order to recognize some crops, for example, you are going to develop a mobile application, okay, that can recognize plants. So that is very much important application of this deep learning system. For example, we have so many plants with us, and we are unaware that what is the name of this plant, what are the medicinal value of this plant. Okay, so you can have design a system that can recognize pictures, and they can identify or extract some kind of medicinal values, okay, that can be used to treat the several kind of diseases. So features you can extract from a plant. The name of plant is unknown to you, features are unknown to you. So deep learning will help you. Just train a system, develop a system that will help you. Yield estimation and prediction is very important. You can predict what will be the amount of yield this year. Okay, so if it is very less, early detection is there. So just you can increase some kind of fertilizers. You can do some kind of other measures to increase the yield estimations. Crop quality detection is also there. Crop yield is very much high, but the quality is very less. We have so many infections with the crop. So just you can identify the crop quality. Stress you can detect, you can monitor the growth. Severity is very important. Okay, I will tell you how you can detect the severity. Few days back, we published an article on the severity detection. I will share the link of that article to you. So there you can identify that what kind of diseases we have. So we worked on Parkinson's disease. We work on this diabetic retinopathy (DR). Okay, so you can work on those kind of things. How you can detect the severity of the human disease as well as plant diseases. Okay, so we have so many applications for this kind of introduction to you. Just I mentioned a few of them. And these are basically components of a plant disease detection system, not a deep learning system. Okay, just we have, for example, we are not having deep learning with us, and we are interested in disease detection with the help of leaves only. So what process you will apply? Just you will start with this input images, that kind of different type of variety of images you have, data sets, already data set we have. Okay, so what kind of image you are going to tackle, what is the fruit yeah, you are going to select, okay, or kind of crop you are going to select. So just select that particular image, apply the pre-processing on it. Okay, so pre-processing is very important. Pre-processing means you are going to remove the noise from image, you are going to increase the images. For example, images are very less, so apply pre-processing techniques like shearing, rotation, you can apply in order to increase the images. Okay, or if images are captured on unfavorable weather conditions, okay, and the orientation of camera is not proper. So for example, whenever we are capturing images from your camera, so orientation is very important, that how much orientation is there. So sometimes pictures are distorted, and they must have noises with them. So just you can pre-process those images intelligently, and so that results will be better. Okay, so don't directly apply images captured from your mobile phone or the drone camera as it is. Just see those images one by one. What mistakes we do in our research work, we download the data sets from repositories like Kaggle, GitHub. Okay, you say repository, so many data set repository we have. So you are going to apply those images directly. You have not seen those images manually. So it is very important that you must see images carefully. If there is a need for any kind of pre-processing, so just you do pre-processing, and then you start further processes like segmentation, feature extraction, selection, and then classification. And after classification, just you are having this disease identification. So this classification is very important. What kind of information you are going to train to the system, on that information only your system is going to tell you the results. Okay, it is in case of CNNs. But in case you need real time, then you may apply some other kind of networks like RNN you can apply. Okay, different other networks we have, so that can learn features on the go. As per the architecture of a CNN model is concerned, we you know that we have input image with us. That image is having dimensions like pixels in the x direction, pixel in the y direction, and we have channels with us, that is, for example, RGB channels with us, red, green and blue. So 3 channel we have. So this input image, for example, we have like say 120 dimension, we have pixels in the x direction, 120 in the y direction, multiply by 3 means we have red, green and blue values with us. So directly we are using 3, but in general, you can say if we are having RGB values in your system, so R means, for example, how many bits you are using to display a pixel for a color. Okay, so for example, I am interested in red color, so and green color and blue color. My bits are, for example, 24. So it means 8 bits I am using for the red color, 8 bits I am using for the green color, and 8 bits I am using for the blue color. So total, we can say combinations we have, that is 2 to the power 24. Okay, means 2 to the power 8 type of red color we have, starting from 00000 to 1111. Same for the green, same for the blue. So a pixel can have any value that ranges from 24 zeros to 24 ones, and then ones. So we are interested in the pixel values. For example, this pixel 00 pixel is there. So what is the value of that pixel? So you are you are converting this image to the numerical data, and then only you can identify what was the numerical value for that image, and what is the numerical value for the testing image. Based on that, you can have some kind of comparison that will tell you that this output is a kind of like a plant we have, or it is a cat, it is a dog, it is a car. Okay, so classification basically depends on such kind of features only. So whenever you are taking input as an image, just you are applying some filters on this image. So filters must be applied carefully, that which kind of features you are interested. And after applying convolution layer, you have a feature map with you. Then you can apply the pooling layer. Okay, so that is going to take we can say best part, or we can say maximum part. Okay, just it is we can say uh, based on the concept that the nearest pixels are having the similar values. So just take a bigger value and ignore the smaller value. So that is a pooling layer. And then you can again apply the convolution, and again you can have pooling layer. So this is basically architecture of a convolution neural network. You can develop your own network from scratch, as well as you can use transfer learning in order to train a network. So in case of network training, the weights and bias are very important. That basically optimized by back propagation only. Whenever we are applying the activation functions, so some functions are linear functions, some are non-linear function, like ReLU we are applying. So ReLU function is basically a non-linear function. And why we are applying? Because the computation cost is very much minimized and the output is favorable to us. It basically converts negative value to the zero value and positive to the as it is values. Okay. So this activation function basically helps these networks to train. Whenever you are applying the linear networks, so system is not going to train much. Okay, until unless we have non-linear function with us. So number of layer basically don't affect much as the activation function do. So whenever the neurons in the upcoming layers are not much trained, okay, so we are going to have differences. What is the output? What was the ground truth? So based on these comparisons, we can have differences, that what can be the what is the error we have, and we need to adjust the weight and bias. So that is the back propagation from the upcoming layers to the previous layers. Just you are going to have adjustment of weights and bias, and you can have epochs to all the systems. Okay, how many times you are running the whole system. I will tell you all these things in detail one by one. This is the common, we can say, a block diagram, or we can say overview of a deep learning assisted plant disease detection approach. Okay, in which we basically have a dataset creation process. So this is the first process. What we basically do, either you can create your own dataset or you can utilize the existing dataset. Then you can have pre-processing of the images. Okay, I will tell you what kind of pre-processing you can apply. Then you can train a network, and then you can classify the disease or classify the image that it is a diseased image or not. Okay. And on the other hand, this kind of systems can be applied to some other applications. For example, you can have image of any vehicle, and you are applying these hidden layers, convolution plus ReLU plus pooling, then convolution plus ReLU layer plus pooling layer. Then you are flattening all these images to the vector images, followed by a fully connected. Then we have a softmax layer, and finally you have a result that can tell you that whether it was a car, whether it was a truck, and whether it was a van, bicycle. So these are basically classes. So likewise, you can have classes for your disease plant. Okay? Symptoms, you can have classes like class label is there. So class label means it is diseased, yes, or it is no. These two class label we have. So in case of disease system, that works on the binary system, so you can have two classes, either it is disease image or it is not a disease image. In case you are working on the severity identification, so it is basically a multi-class classification. Multi-class classification means the images for a particular disease are categorized into different severity levels. Like for example, S1, S2, S3, S4, up to, for example, S10 we have. So these are the levels. So depending upon the level, you can identify that what was the level your system identified, and based on that, you can have severity levels with you. So let us discuss these things in detail. If in case you have any queries, then please you can ask. Okay. So the process of a CNN starts with the convolution layer. So what exactly the convolution layer is there? So in case of convolution, we have this image with us that have height, width, and we can say depth. Okay. So number of channels we have. So input to the convolution layer we have. Then we have kernels, or we can say filters, that are that will help you in order to extract the useful features, like as we discussed earlier, like vertical edges or horizontal edges. Okay, so these kind of filters you can set, and then output of this layer is basically multiplication of these two layers, like input and the kernel layers, and then you can extract the maximum value out of these 2 by 2 or 3 by 3, we can say, frames. Okay, so for example, if we are talking about this one frame, so we believe that this pooling layer identifies that these all pixels have green color. So just select this maximum value that is having the high intensity value. Okay, so it will give a good result. So just you can select the maximum value. In case of pooling layer, here you can select the 94 value that are from the blue color, and 83 from this red color, and 60 from this orange color. And then you can apply the fully connected layer that will tell you the final output. So convolution layer basically used to extract the features from the input. Whenever we are discussing deep learning models, so we are interested in features, feature engineering. So you have to extract the feature from the input, and each layer has set of filters. Okay, like 3 filter you can use, 5 filter you can use, 7 filter you can use. Okay, that are basically odd values, and careful examination of filters is very important, that what kind of filters are important to you. Then you can apply the activation unit. Generally, we apply the ReLU. I will tell you some other activation functions as well. And then you can have a comparison that which activation function gives you the better output. Okay, so that can be sigmoid function, tanh function. Okay, so these kind of functions you can have. ReLU basically is very important, very famous nowadays. It gives you a correct output, as well as the processing time of the system is very less. And here the unit basically convert data into the non-linear form. So this is very important. As mentioned earlier, non-linearity is very important in case of neural network. Whenever the activation function is linear, so neurons are not going to be learn much. Okay, because in case of back propagation, you are going to adjust the weights and bias due to this non-linearity concept only. Okay, the output of ReLU is basically then passed through a pooling layer, and pooling layer basically remove any redundant features that are captured during the convolution. Okay, so you can say redundant features means these are redundant. 78, 67, 56, 12. These are redundant. They will give you this green color only. But for example, 78 is having high intensity. This will give you the better result. So just we are removing the redundant values in order to process or in order to develop a faster system that will learn the features in a very less amount of time. Time is very important. For example, you are applying Google Lens. I hope many of you have used this Google Lens or any kind of mobile app for plant identification or plant disease that basically captures the images, and on a frequent of seconds or very much less time they will take, and they will provide you the results. And just a minute. So this is basically removing redundant features. What features you are going to remove? That is the meaning of pooling layer. So we are pooling the higher value only, and we are ignoring the lower values only. And then the process is passing data through convolution pooling layer successfully repeated as per the design of the model. Okay, so number of layers you can increase or decrease. Okay, so for example, you can do a testing that I am developing a system with 3 layers that is giving me some value like accuracy with 98%, or we can say 96%. If I am applying more values, so it doesn't means that if hidden layer are 5, so that accuracy will be more, that can be less. Okay, so this selection of parameter is very important, that how many layers you need and how much accuracy you are getting from your data. Okay, as mentioned earlier, interpretability in kind of CNN model is very difficult. It is a kind of hit and trial model. So in case you are confused, better to use transfer learning concept, directly apply the trained weights and bias values that are optimized one. In case you are confused with the optimized values, then you can also apply optimized optimization concepts also with the help of meta heuristics. So you will also find some paper that applied meta heuristics like swarm intelligence we have. Okay, that are, we can say, population based meta heuristic techniques like gray wolf optimization we have, particle swarm optimization we have, count colony optimization, genetic algorithm, honeybee algorithm. So various swarm intelligence based techniques also exist in the research literature. You can have a system that can optimize your weights and bias by meta heuristic techniques. Okay, that is also a kind of innovation to your work. And I also read some papers that worked on the collaborative, or we can say hybrid model, CNN plus meta heuristics. Okay, definitely results will be encouraging to you. Okay, so you can repeat layers as well as you can apply meta heuristics to your work. And basically, whenever we are scanning a data set of the leaf images, you extract the essential features before classifying. So the output of CNN model is basically calculated using a softmax function. Softmax function basically preferred because it gives the probability of the output of for different classes rather than just, we can say, 0.5 in case of sigmoid output. So why this is preferred? Because it gives the probability of the output of different classes. Okay, so if correlative effect, we can say you can have, so we have n number of classes. So the probability of all n classes basically takes into account, and depending upon all these things, softmax will give you the output that will take into consideration the probability of different cases. So for accurate classification, proper training of a classifier is required. That can be plant images, that can be your medical images. So training is very important. So proper training is required, and then features basically you can extract from segmented lesions, and these segmented lesions are basically part of a pre-process. So sometimes we applied lots of training, but the accuracy is not much high. So why I mentioned this one at the end, because in case of pre-processing, segmented lesion is not identified. For example, you are interested in identification of a kidney stone from, you can say, CT images, from X-ray images. Okay, so the region of interest is very important. So it is very important that a good segmentation technique must be applied on these X-ray images as well as on these CT scan, any kind of other images like any radiographs you have. So you have to apply segmentation in order to identify a particular area in which the kidney stone is there. So labeling is very important, segmentation is very important. All these things clubbed together makes, or we can say learns the system very much. It is not the case that you just adjust the parameters, set the hidden layer, set the filters, and then again you are doing experiments and still results are not encouraging. So just have a clear insight on the images, what you are using, whether region of interest is clearly mentioned, whether the symptoms, or we can say diseased portion, textures are clearly indicated on the image. If not, then please use a labeling tool, use segmentations and identify those areas of interest, and then apply the training part. Then only you can have a good results. Okay, so this is the summary of this layer wise CNN convolution layer extract feature from the input data. It is a filter between the input and the output. So what kind of filter you are applying? Just for example, vertical edge we need, horizontal edge we need, some kind of other textual regions we need, some spots we have. Okay, so just filter those particular areas from an image. So whenever you apply a filter, definitely you can see the changes from the plain image to the filtered image. So only required portion is filtered by these layers, and that filtered image is going to be trained to the system. Okay, so just you are ignoring all the concepts. So for example, if you are interested in training a mobile phone, so you are ignoring all the other areas, just focus on this mobile phone only, then only you will be trained. Okay, and whenever I will give you some input that please tell me what is this, this is a mouse, this is a bottle. Okay, so just you are comparing the features of this mobile bottle and all these things with your mobile phone, and then you will tell whether the class level is mobile phone or some other. So class labeling is very important. In case of deep learning, machine learning, AI, class label is very important. What is the class? Okay, so if class level is known to you, then you can train the system very much easily. If class level is not known to you, it means you are going to apply the class labeling. So labeling tools are available. Many tools are available on nowadays, and you can apply those kind of tools for proper labeling that will convert your images and data to the XML form, and then from that data your system can train, and then you can have a final model with you. Okay, so class labeling is very important so that the filter will work better. And feature map basically takes the input and summarizes the detected features. So feature map is nothing, it is just a we can say map or a kind of a matrix that will summarize the detected features. And this layer basically break down image into important features, then predicts a label based on those features as mentioned earlier. So this is the summary of the convolution layer. Then we have a pooling layer. It basically simplify the computation by reducing the dimensionality. So it do basically two things. One is it reduce the complexity because we are selecting only few portions as we see in this one. So only one value is of interest to us. Rest three we are ignoring. So we are reducing the dimensionality of the data. Okay, and is basically combines the output of one layer before proceeding to the next layer. This is very important. Whenever you are proceeding to the next layer, so you are just going to have output of this layer. So you are going to summarize the output of this layer in order to provide input to the another layer. So pooling layer is just summarizing the output, combines the output of one layer before proceeding to the next layer. So layer wise combination is also done by the pooling layer. So it is very important. Fully connected layer is basically whenever you are providing output in the form of final pooling layer. Okay, so final pooling layer is means you are combining data from the previous layer that have result of all the previous layers. So that's why it is a final connected layer, fully connected layer. In which flattening is there, it means you are putting matrix wise data to the vector wise data. So this flattening is there, and then again you are creating image from those pixel values, and then you can analyze what are the what were the class labels. So let us have some more detailed insight on the activation functions. What is the purpose of the activation function? Why we need activation function, and what is the best and activation function? So activation function basically decides whether a neuron should be activated or not. So you can imagine your human brain. Can anyone tell how much neurons we have on our human brain? What is the size of neurons? Any person from the participants?
Few billion.
Can you tell me any number?
$86 billion.
Which one?
86 billion neurons we have in our brain, I think. That is the number.
Okay. Any other, please?
Approximate 12 billion.
12 billion. Good number. So approximate number is 10 to the power 24. This is basically number of neurons we have in our human brain, and the activation of a particular neuron basically is decided that which portion is being affected. So you are also interested in this plant disease detection, or we can say kidney detection, or any kind of retina detection, glaucoma detection. Many applications we have for this deep learning system. So you must be interested that what whether a neuron should be activated or not by calculating a weighted sum and further adding bias to it. So we have so many neurons with us. Neurons means some kind of properties we have. So whether we are going to activate this neuron, whether we are going to activate this neuron, or whether we are going to activate this neuron. So depending upon the weighted sum and bias, this activation function decides whether we should activate it or not. So the purpose of the activation function is to introduce a non-linearity into the output. It is not linear that we are taking output of each and every neuron. We are taking non-linearity, that sometimes we are interested in those features only, sometimes we are interested in those features only. For example, you are interested in buying a home in a city. So whenever you are buying a home in a city, what features, what properties you will look? Whether it is approachable to bus stand, whether it is approachable to railway station, whether highway is near to you, whether hospital is near to you, whether school is near to you, what is the cost, what is the, we can say, future rates of this property. So such kind of features you are going to select. It is non-linear. It is not that you are taking all these things and your budget is very low. Your budget is, for example, 10 lakhs, and you are looking to all the properties that it must be near to the bus stand, it must be near to the railway station, highway, hospital, school, everything is there. So definitely the amount will be more required. So if you are interested in two things, for example, you need public transport. So you will select only two features. So non-linearity is very much important, that which kind of features you are interested. For example, ReLU function I am applying. So rectified linear unit, this the full form of this function is there. So I am interested that what are the positive values. So these features I am going to select only. Negative values will be discarded and they will be converted to zero values. This is basically the purpose of this activation function. Okay, so what kind of neurons you need to be activated? So we are discarding all these things. Positive value will be used as it is, but these negative values, they will be discarded by the activation function. And that is basically used with the help of back propagation. For the detailed discussion on this activation function, I will share this PPT with you. Just you can click on those links and then you can have detailed insights on this, what is the back propagation and how it is working in these kind of neural networks.
Excuse me, sir.
Yes.
Excuse me, sir. Sir, here in the previous slide, by means of neuron, you are trying to point out feature or something else. One feature. Neuron means one feature.
Neurons, yes, neurons basically properties. Okay, so you have a data set like we have images with us. So for example, you are having 1,000 images with you. Okay, and you are putting those 1,000 images in the form of some pixel values to your system, and those systems are basically extracting those neurons are basically extracting features from those images. So which features you are interested? So basically, in order to extract the useful features, you are applying these kind of functions.
Okay.
So for example, you need a function or your system needs some kind of functions that are having values like -1 is there and this is 1 is there. You need a system that works between these two values, -1 to 1. So you are going to apply the 10H function. If you need a value that works between 0 to 1, so you can have this sigmoid function. And if you need the, we can say non-linear values, like if 0 for other values, negative values, we have for all negative value, we have 0 value. And for all positive value, we have X value. What is the value of the X? Okay. So 0 to infinity, we have this ReLU. And from -infinity to infinity, you can apply the linear functions. So depend upon the requirements, you can select activation functions. Okay, it is not the case that you are training a system with plant disease detection or any healthcare system, and you are applying such kind of activation function like let me apply 10H, let me apply sigmoid, let me apply linear function. What is the result? So it will take lots of time. So what is the advantage of attending such kind of things? You know that ReLU is very important and it is suitable for all kind of deep learning systems that will work on such classification systems. So don't waste your time in just hit and trial, just select 10H function, sigmoid function, linear function, and let's see what is the result. Okay. So a neural network without an activation function is basically a kind of a linear regression based on the current data. Just you are reading that what will the predicted values. So we are not interested in the linear regression values. We are interested in the back propagation values. We are going to optimize the weight and bias for the neurons. Okay, then only you can have correct filters with you. The whole task of this neural network, or we can say CNN, is to have a correct training. Correct training means that is derived from the extracted features only, and features means that features in which we are interested. Like you are interested in lesion spots of the infected plant. So we are extracting those features only. Then only your system will compare those features to the tested image, and then it will compare that yes, this image is not containing those features. So we can say that this is not a diseased plant. This is the whole picture in our front. Pre-processing is very, very important. What mistakes we generally do: download the data from the Kaggle, or we can say GitHub, any other repository. We have so much amount of huge repository we have in terabyte, gigabyte data we have, but we are not applying these pre-processing techniques on the data and feeding data directly to the system, that may result in the you can say bad results, not good results. So we have resizing with us. If dimensions are very much high, like 512 by 512 pixels we have, so just you can reduce it to 256 by 256 in case your system is not much capable. You are not using high-end GPUs, okay? So you can utilize or you can resize. That will also serve the purpose, okay? But not too much extent, but for understanding purposes, for learning purposes. In case you have high-end machines, then you can apply the high dimension pictures. So just you can resize the pictures, okay? Larger to smaller you can do in an easy way, but smaller to larger is not, we can say, correct one. It will not reflect all the features as it is, okay? Noise removal is very important. Sometimes we have unfavorable weather conditions, light is not proper, and camera orientation is very bad. It is not correct. We know that we have projections like parallel projection, perspective projection. So in case of correct image, parallel projection is preferred, okay? So parallel projection is, you must apply, you must have a 90-degree angle of your camera to the leaf, okay? If it is tilted, so just tilt your camera, okay? The bigger challenge in such kind of systems is that, especially in case of plant disease, leaves are not, we can say, very much visible to the to us, to human beings. Suppose we have a larger tree, larger plant that is, for example, 3 feet long, and we are just taking images from upper part of that plant only using drones, but there may be some kind of infections that starts growing from the stem part or from the lower part of that particular plant, okay? So you must utilize those images carefully. Just by applying or by utilizing the camera images from top does not suffice the purpose, and you will not sit relaxed that yes, my plant or my farm is okay, there is no disease, because you have captured images from the drones and that obtained images from top part of the plant only. So it is very important that few images must be taken from the lower part of the plant, not from the whole we can say farm. Just you can take samples from some areas, okay? So you can divide your whole farm into 4 regions or 5 regions or 6 regions, and you can take samples from every region, okay? Like few images from this region, few images from this region, few images from this region, few from this region. These are images for the lower part of that particular plant, okay? So don't depend on the upper part only, and don't depend on the ready-made data sets. Just you can create your own data and then you can test the system. That will, we can say, give more motivation to you, and that will give more innovation to your system, okay? Transformation is very important. Whenever you can transform like color images to grayscale images, okay? Sometimes you can see many scholars are saying that I converted my RGB image to grayscale image. So why you do that? Okay, sometimes there is the requirement for the system that you need images with only 2 channels, okay? So you can transform your image, but not, it is not necessary that all the time you will transform. So whenever you are transforming the images, you must ensure that your information must be retained, okay? Sometimes the like in case of plant diseases, color changes is a symptom. If your plant leaf is green few days back and now it is yellow, so what are the reasons for that? Maybe excess water you applied. You can also test, for example, you have you may have plants to your homes, tulsi plant you have, another plant you have, just provide excess water to that plant and you can see the result in few days. Leaves will be converted to some other color, like they will be yellow, or they will be some other kind of texture you will see. Okay, so don't transform your images to grayscale unless it is required in case of plant disease detection system. In case of other systems like kidney detection or any other kind of glaucoma detection, so just you can apply some kind of transformation to some extent, but not to a great extent. Scaling basically helps you in order to augment the data, also in order to extract the features. For example, in a small image, the portion or the required portion is not visible. So whenever you are providing labeling, or we can say bounded box, you apply. So just you can select the image or scale that particular portion only. So first you can crop a particular portion and then you can scale it to, you can enlarge it or you can reduce it. By applying rotation and shearing, you can increase the data because the data requirements are very much high in case of deep learning systems. And this is very, we can say, challenging for most of the researchers. They are, we can say, they don't have much amount of data with them. So they are claiming that, sir, data is not available. Only 1 or 2 data sets are there. And many researchers worked on those kind of data. So what will be the novelty in my system? So just you can create your own data, just capture some images, like 100 images you captured, then you apply rotation, shearing, other transformation that you can increase, and then further you can have some other images. So you can create your own data sets. Smoothing you can done, okay, you can remove, we can say, extra, we can say, edges to your systems, to your pictures, so that you can smooth the images. Segmentation is very, very important. It is another, we can say, area, another research area. Segmentation is very important. Sometimes researchers are focused on this segmentation only. Their PhD, their MTech, their higher educations are basically focused on segmentation only. So this is also a good area in which you can focus that what kind of segmentation is required, what are the existing techniques, what are the problems. Basically, whenever we are doing any kind of research, so we have 4 points that are in our mind. Means what is the problem in the existing systems? First of all, you have to identify, okay, and then you can identify what are the existing solutions for that. First of all, I will brief 4 points, and that will help you in order to start or in order to complete your research. What is the problem? This is very important. Problem identification, problem statement is very, very, very important. Okay. So without knowing the problem, we started the research. We are a research scholar and we already spent 2 or 3 years of our precious important time. And till date, after 3 years, we are unaware that what is the problem for which we are finding a solution. So this is the very important term, very important thing, that you have to identify the problem. And problem identification can only be done from reading good research paper. First of all, identify journals. I hope you all are aware about this Web of Science and Scopus indexed journals. So that will suffice the purpose. So just you can read the paper that are indexed in Web of Science and Scopus. Web of Science is basically indexed by a Clarivate Analytics company, and Scopus is basically owned by elsewhere. So just you can read the article from this both indexing. Can anyone tell me what is the difference between Web of Science and Scopus indexes? Yes, participants, please. Can anyone tell me what is the difference? I am not talking about which one is more popular and which one is more famous, which one is more preferred. Just what is the difference between Web of Science and Scopus indexing? Okay, so just I will tell you, in case of Scopus, your article is being indexed. Okay. In case of Web of Science, journal is indexed. Okay, so you can see journals in case of Web of Science, but in case of Scopus, articles and associated information, that is also journals. Okay, so basically we are interested in these two categories in order to identify what is the problem. Second is what are the existing solutions. Definitely the problem what we identified may have so many solutions with us. So we must be interested in existing solutions. What are the existing solutions? And then we will identify what are the loopholes, or we can say problems in those systems. And finally, we will see what will be our solution that overcomes the problem of existing systems, thereby solving this problem. So our target is to solve the problem. Now, in case of plant disease detection system, what is the main problem we have? The problem is we don't have systems that are very much precise and that are containing so much variety of crops. I will tell you a diagram where we compared a few crops on which few works are being done. So you can identify some crops where very much less work is there. You can develop system for those plants. And in case of unavailability of data, you can create your own data. You can identify some regions like in your India, you can identify like Punjab region is there, UP region is there, Rajasthan region is there. And for a particular crop, symptoms may be different. It is not the case that symptom of a pearl millet disease at Rajasthan and that is affected by some fungal infection will be same as in Telangana. Okay, so that may be different. So you have to identify the regions, you can identify the plants, and then you can apply the architectures, which architecture you are going to adopt. Okay, so these things we covered: segmentation, labeling. So many labeling tools are available. Just you can explore those things, those labels, and you can directly apply labeling. Then you can have classification approaches. So this is a common approach, common we can say classification, in which we have unsupervised classification and we have supervised classification with us. Basically, what is the difference between unsupervised and supervised? The difference of a class label. In case of unsupervised classification, class label is unknown. It is not known in data that whether this picture is suffered from a disease or not. So it is unknown. So you just apply K-means clustering algorithm, fuzzy C-means, linear discriminant analysis. We can, okay, so you can apply these things that will automatically try to identify some labels, it will try to predict some labels. But this is not very much useful in case of these image-based systems or deep learning system. So you are interested in supervised classifier. So in case of supervised classifier, we have naive-Bayes, ANN, decision tree, AdaBoost, SVM, KNN. So much classifiers we have. Depending upon the type of data, depending on the type of requirements, you can select the networks that whether convolution network is important to you, whether feed-forward network is important to you, or whether some naive-Bayes classifier is important to you. Okay, so data requirements are data, we can say requirement for running those algorithms may be different. Other approaches we have vegetation indexes. It means like an NDVI, normalized vegetation index. You can utilize to identify that which portion of your farm is suffering from lack of nutrition. Whether you will see, for example, this is my whole farm, and from this drone image, you can see that this portion is having a high temperature. Okay, so from thermal cameras you can capture the images, and then you can apply vegetation indexes in order to extract such kind of information, like there is some yellowness is there, so there may be some nutritional deficiency to this area, and this area is very much good. So why this is affected? Because there may be some kind of slope in this area where more water, we can say, is there. So these things are also important. We also published some articles on this vegetation indexes. Several indexes are there, and you can adopt any index according to your requirements. Okay, so you can select any approach that is suitable to your work only. Now we have confusions sometimes between architectures and frameworks. Okay, sometimes we are using these terms interchangeably, that what is this Leanet, what is Keras, what is Cafe, what is PyTorch. Okay, so for just common understanding, for briefing these concepts, let me tell you, architectures are basically, we can say, a architecture of a scene and model. So in case of deep learning, we have convolutional neural networks, we have recurrent neural networks. Okay, so which type of network you are using, and in that particular network, how many layers are there, how many filters are there, what is the padding, what is pooling, what is threading. So you are having different architectures. These are very famous architectures. They are, we can say, pre-trained networks, trained from different data sets. Like for example, we have ImageNet data with us. I hope many of you are aware about this ImageNet data. So ImageNet data contains billions of images, and it contains lots of classes, like it can have animals, it can have vehicles, it can have like bottles, mobile phones, so many classes we have. So these architectures are basically convolutional neural networks that are trained on this ImageNet data set, and you are going to apply their trained parameters as it is to your system, thereby customizing your convolutional network. Okay, so whenever you are customizing a system, it means you are using the trained parameters. So VGG 16, for example, we have. So VGG 16 is containing 16 hidden layers. VGG 19, it is containing 19 hidden layers. So out of these 16 and 19 hidden layers, you are using the pre-trained network. Likewise, ResNet 50 is there, so it is using 50 hidden layers. DenseNet, Inception, SqueezeNet. So each of these architectures are basically already gained popularity, and they already gained some, we can say, prizes in competitions organized by ImageNet, PlantNet. Okay, so these are architectures. Frameworks are basically libraries. Okay, libraries that are containing codes, some functions, ready-made functions. Directly you can adopt those functions, and you can train your network. Like TensorFlow is there, Keras is there, Cafe is there, PyTorch. So depending upon the requirement, you can select the libraries. So as we know that library contains so many books, so like we have 1,000 number of books. So what we are doing, this book number, for example, 550 is important to us. So just capture this 550, read it, and return to the library. So just you are capturing TensorFlow, you are implementing TensorFlow, you are including TensorFlow to your code, execute its functions, and then return back. So this is basically the difference between architecture and framework. So don't confuse that. What is the difference between architecture and the framework? These are some famous Python and Java libraries. In addition to this, we have MATLAB frameworks also for deep learning. Okay, so you can utilize anyone. The usage of framework is not important. You can use any framework. Okay, you can use any programming language. It is not that if you are going to apply deep learning, then Python must be there and you must know the Python. It is not the case. You can apply these things into any other language, like MATLAB you can apply. Okay, so in MATLAB you can also train. You can apply another programming language. So dependency on the framework should not be there. You must know the hidden facts that are responsible for training of these kind of systems. Then this transfer learning is very much gaining popularity nowadays. You can utilize the knowledge of existing models to the new problems. For example, I am having a network that is already trained on trucks. Train on trucks means that can identify from an image that whether truck is present or not. So you can apply the knowledge of this network to some new problem to identify cars. Okay, that is the basically purpose of using or utilizing the existing models. And with transfer learning, we can provide training to the deep network with the limited data, because already the network is trained. We have optimized parameter with us. So with very few data, just you can utilize the trained network and you can provide training to your network. And we basically transfer learning try to use what we have learned for one task to apply to the another task. Weights are being automatically being shifted to a network from task A to task B. That is basically shifting of the task. And scene architectures are basically trained through back propagation algorithms for tuning of weights and bias. This is very important. This is not a feed forward network. This is basically back propagation, because you are interested in what was the ground truth and what was the result. Okay. This is a transfer learning illustration for VGG19 model. Just you have source image dataset from ImageNet dataset, and this VGG19 is already trained on ImageNet model. So transfer the weights and parameter to the custom model. So this is your custom model. Okay. So custom model basically uses the weights and parameters of VGG19 that is already trained on ImageNet model, and you are using this data and parameters of VGG19 in order to extract the features from VGG19 model. Okay. So modify the network structure and fine tune the network. So upcoming or higher layers, you can identify that what are the max classification you are going to use, inception module you are going to use, or you can take data from other networks as well. Okay. These are famous data sets, plant image, ImageNet data for these plant leaf disease detection system, plant village data set developed by SP Monti and all. It is very, very popular data, and it contains lots of classes starting from apple, tomato, blueberry, okay, peach. So many plants you will find here, and you can use the knowledge of transfer learning for your particular plant. As per the performance metrics are concerned, we know that we are going to identify the error from real outcome, what was the real and what are the predicted outcome. So predicted outcome basically y cap. So y cap minus y you are going to identify, that is the error. So if error is more, it means your predicted value is not, we can say, aligned with the real outcome. So in order to have analysis on your system that whether this system is performing very much or not, so you have these metrics like true positive we have. That means you are going to predict, the system is predicting positive value and that was already positive. Okay, so just I will conclude my session within 5 minutes. True positive means predicted value is positive and actual was positive. Okay, in case of negative, predicted value is negative and actually it was also negative. That is true negative. In case of false positive, it predicted positive value but actually it was negative. And in case of false negative, it predicted negative but it was positive. And based on all these things, you can create a confusion matrix that can tell you what is the accuracy, what is the recall, what is the specificity, what is the F1 score for your system. As mentioned earlier, accuracy is not the important metric for you. It is not a great metric. Okay, so it is, please focus on this one. Just we are considering that what is the accuracy of my system. So first of all, you must know whether your data is balanced or imbalanced. Can anyone tell me what is the difference between balanced data and imbalanced data? Yes, what is balanced and imbalanced data?
If the data is not normalized, it would be called as imbalanced data.
What do you mean by normalization?
Let's say for yesterday, ma'am has taken an example of heart this thing, where age had many numbers, and whereas heart disease was counted as either yes or no. In the sense.
Okay. Any other?
So,
Sir, when there is a too much difference between the two classes in the data set.
Yes. This is correct one.
yes,
Right.
actually, I was about to, thank you, sir.
Okay. So balanced means, for example, we have a data set that contains 1,000 images, and out of 1,000 images, 500 are of yes class, 500 belong to no class. If this is the case, then only you are going to consider the accuracy metric. Otherwise, please don't focus more on this accuracy. You can focus more on the F1 score. This is very important. That basically know or basically tell you the harmonic mean of precision recall. Precision recall means what is the correct classification rate. So proportion of positive predictions that was actually correct, that is tell by the precision one. So true positive by true positive plus false positive. You must remember these metrics and try to identify the reasons behind that. Don't just cram all these things. In case of recall, or we can say recall is also known as sensitivity, true positive rate, or hit rate. Like precision, it aims at measuring what portion of actual positive was identified, but it takes into account false negative as well. So both metrics will give you the idea that what is the correct classification rate. Okay, so don't focus more on the accuracy. Other than these metrics, we have ROC curve, so receiver operating characteristic curve. So you can also identify what is the region or area under ROC. Okay, so this area indicates the classification of all classes. It takes into account the result of all classes, not for the one class. So this also indicate a classification rate. Okay, so it doesn't mean that if prediction is 0.95, so it may be a low performance model because it is having a recall 0. So selection of right performance metric is very important. So just select the right metric for your work. Don't focus blindly on the accuracy only. Focus on recall and we can say precision also. And I will conclude within 2 minutes only. Just how you can start.
No, patkom, ammai this.
Pardon, please. Any participant are saying something?
Sorry, sir.
Excuse me, sir.
Yes.
Can you please repeat recall metrics?
Recall.
Yes, sir.
Recall basically takes into account the proportion of true positive by true positive plus false negative. It means your system does not only says that if disease was present in a leaf, okay, and your system says that disease was present. In addition, your system says that disease was not present. This is very important. So in only you are focusing on disease. If it is yes, you are also interested in false negatives. How much negatives were there? Okay, that is a recall. So
Right, sir. Right.
proportion gives the correct classification. Then when you are going to start, so just read the research literature. Research literature means read review articles. So first of all, start with the review articles. You can write review articles. Review article of 2 types: systematic review and comprehensive review. I can tell you all these things later on I have published few research articles that are systematic as well as comprehensive. So for detailed guide, you can discuss with me later on after this workshop as well, because for the time constraint, I can't explain how you can write a review article. This is the first step to start your research, because for the last 10 years, last 20 years, what research was done by the scholar. So just you have a systematic review or a comprehensive review, and then only you can have a picture that yes, this is my problem. Now I have to focus the problem. So first 1 year or 1.5 or 2 years of your PhD should be focused on problem identification, that what are the work done by researchers. Then identify plants. What are the plants? So for example, you can see this is done by us, like in Apple. These three authors discussed much accuracy, like 90.4 accuracy we have, 97 with AlexNet, 90 by VGG, 97 by AlexNet also. So such kind of comparison you can have. Cucumber only 2. In case of tomato, you can see many researchers are working. Okay, already they are promoting 99.18 accuracy with Google Net network and maybe on ImageNet data. Okay, so don't focus much on these kind of plants. So identify plants that are important to you, and then specific portions, stem, roots, leaves. Definitely more focus on the leaves. Then methods of interest, which method are suitable to you, data collection, pre-processing, feature extraction, and then severity as well as you can do. These are basically challenges. Quality and quantity of images is very less. So you are going to increase the quality, you are going to increase the quantity of the images. Noisy and bad weather conditions are also challenging for collecting the images. Classification is very much challenging, which type of classifier you are going to use. Colors of the leaves, you have to consider that whether the leaf color are important to you or not. Symptoms can be different by diseases as well as regions. Okay, like I discussed Punjab, Rajasthan, Haryana, Telangana. So you can select regions as well as, and you can select plant. And you can then identify hidden parts of a plant that are not captured by automated systems. So manual inspection of such things is also important, and you can capture some images. These are some famous journals for plant disease identification systems, like Computers and Electronics in Agriculture, Frontiers in Plant Science, Journal of Plant Disease and Protection, Agriculture. So links are available to all these journals. These are very few and these are very famous. And in addition, you can identify some other journals from reputed publishers that are indexed in Web of Science and Scopus. These are references that I utilized to prepare this PPT for you. And this 4th and 5th number article basically written by me and my team. They are basically 2 review articles. So first review article is basically survey of deep CNN models for prediction of plant leaf disease, that is published in Sensor Journal of MDPI. So in this paper, you will see that what are different type of architectures. So there we explained this AlexNet, VGGNet, Inception, GoogleNet. Each article is explained along with all the performance metrics, comparison with other data sets are also available. So it is a kind of a repository that contains research of last, we can say 10 to 15 years. Same for like multidisciplinary disease we have, that is Parkinson's disease, diabetic retinopathy. From those images, we try to identify severity and papers considering severity from those images only. Okay, so this is published in this year also in Diagnostic Journal of MDPI. So these are 2 articles. Please read all the articles, like these 7 to 8 articles are there. And in case you need any kind of assistance in writing a review article, so just you can write to me. My contact details are mentioned here. That's all from my side. That was